Now let's get started. So first, I'll do some light introduction of StarRocks and StarRocks' relationship with AWS Graviton. Uh, just a few minutes. So StarRocks is a Apache licensed open source query engine and data warehouse, right? It can be used as a data warehouse for real-time analytics workloads, right? Storage engine enables real-time mutable data directly on its columnar storage, around 10-second data freshness, even with mutable data, right? Sub-second query performance at scale, best-in-class query performance. Also features a storage compute separated architecture, right? Basically means store your StarRocks files, persist them in a remote object storage such as AWS S3. And if you ditch the StarRocks storage engine, it can actually fit into the lakehouse, the open data lakehouse architecture, right? It natively integrates with Delta Lake, Apache Iceberg, Apache Hudi, right? It's a newer generation of query engine that's really focused on those low latency, high concurrency, customer facing like workloads, right? You're able to get data warehouse like performance on the data lakehouse on your Apache Iceberg tables. One thing I always trust StarRocks about is its query performance, right? Always deliver the best possible performance and the best cost efficiency. But query performance is not only software, right? It's software and the hardware. And what hardware you run StarRocks on plays a huge role into what end result you're gonna get, right? And this is Graviton. So this is the latest benchmark report we just got. StarRocks on top of Graviton, on top of Intel chips, both served in AWS EC2 instances, right? So on TPC-DS 1 terabyte, uh, Graviton 4, so CAG, is 70 times more cost efficient than C7i, which is the last gen, I think this generation Intel chip, right? So the cost is calculated by the cost of each instance times per unit time times the total query time and then the cost, right? So, and now I'll hand everything over to Mario, and he's gonna dive deep into Graviton and how Graviton is able to achieve this kind of crazy cost efficiency. Mario,
Thank you.
it's all yours.
Let me see if I can share my screen.
Mm-hmm.
And
The play. Yep.
looks good.
Yep.
All right. Well, I just want to briefly introduce myself. I'm Mario Popish. I'm a senior partner solution architect at AWS. That means I help partners use Graviton and help customers find success on Graviton. Been with AWS for the last 15 years, helping customers do just that, building their businesses and leveraging the best that AWS has to offer. I'm going to cover just a brief agenda. What I like to do in these is I tell these stories kind of like an investigative reporter. So I'm going to spell out a little bit about the who, what, where, when, and why of AWS, of EC2, of Graviton processors, of StarRocks on Graviton processors, and then of course, like a good investigative reporter, I'll tell you what my call to action is before I even get to that point. It's to try StarRocks on Graviton processors. With that, why do customers choose AWS? Well, first, what is AWS? I suppose you all probably know this already, but bears repeating, AWS is the world's most comprehensive and broadly adopted cloud, offering over 200 fully featured services from data centers around the world. Millions of customers, including the fastest growing startups, largest enterprises, and leading government agencies are using AWS to become more agile, to lower their costs, and to innovate faster. There's really 6 core themes that make AWS stand out, and that's the leadership, the operational resilience, the long-term value, the culture of innovation, the breadth and depth of our services, and the community. With over 1 million customers, a great partner community with partners like StarRocks and SolarData, really making AWS a really powerful solution. Today, AWS Cloud spans 120 availability zones across 38 geographic regions. So AWS has the global reach and scale to really help you succeed in your business. Like I said, I'm also going to tell you about EC2 and why EC2 is the broadest and deepest compute platform choice for your computational needs. EC2 offers a broad array of categories of types of EC2 instances, everything from general purpose burstable instances, compute-intensive instances. These are probably the best choice for running StarRocks in the compute-intensive instances. Memory-intensive instances, so much so that you can really have an incredible amount of memory in these instances. Dense storage or high I/O storage, GPU instances. We also offer a broad array of processor choice, including some accelerated compute offerings. We have more than just AWS Graviton as our custom silicon. We have Inferentia for doing machine inference, and Trainium for doing machine learning training, as well as GPUs and FPGAs. We actually have a new generation of FPGAs available today. Networking is another real strong capability of AWS EC2. The the C8GN has a network enhanced instance that offers up to 600 gigabits of network throughput. If you want to use the Elastic Fabric adapter, that's what EFA is, you can get up to 3.2 terabits between inter-instance communication. We also offer bare metal instances. We offer instances that are the right size for any of your workloads, right? Everything, we use kind of t-shirt sizing to describe the instance sizes, and these basically double as they go up. Everything from a nano-sized instance to a 224 XL, which is larger even than my shirt. These also come with options. I mentioned the Elastic Fabric adapter for that 3.2 terabit a second for inter-instance communication. We also offer elastic block storage to meet any of your storage needs. When you combine all of these, we have over 850 different instance types for virtually every workload and business need in EC2. I mentioned this broad processor choice. I'm here to talk to you about Graviton, but there's also Intel and AMD and Apple Silicon. You can actually use Apple instances in the cloud on either x86 or ARM-based processors. So broad choice of processors and architectures available on AWS. I just needed to mention these kind of names. I know this just looks like a lot of names and numbers, but StarRocks' most recent testing was done on the C8G. We kind of use this first letter as the instance family, C being compute optimized, and the second character here is a number, and that's the instance generation. We're on our 8th generation of EC2 instances these days. We've actually just launched 8th generation of Intel processor as well. That's only, I think, available in the memory optimized family, the R8i instance. But I'm here to talk about Graviton, so these are all Graviton instances on this slide. But to tell you a little bit more about Graviton and why this is particularly important for StarRocks performance, you can see in this slide that we've continued to improve the compute performance of Graviton over time. When we launched the first generation of AWS Graviton back in 2018, we offered it at up to a 45% cost reduction comparable to other instances, non-Graviton instances. We really built this kind of as a proof of concept that ARM-based processors would work in the cloud or applicable to data centers. ARM-based processors are the most popular processors in the world. You're probably more familiar with them in cell phones and embedded devices, but they're really taking off in data centers. So that was our first generation. In our second generation, this is when we started to recognize that customers wanted to scale up and not just out with Graviton processors. This offered up to 40% better price performance compared to other instances. By the time we launched the third generation of Graviton, we started just comparing it to prior generations of Graviton because we didn't want to compare it to the other instances as it was just getting so good. The third generation offered up to 25% better compute performance, doubled the floating point performance of Graviton 2. This is a huge leap. Graviton 3 really well established and people love running it. With Graviton 4, once again, we upped the compute performance. We added more cores and we added a lot more memory bandwidth. So why Graviton? It offers the best price performance. You got to see some of that comparing current generation of Graviton 4 and Intel instances, just kind of in the introduction, but it really offers the best price performance in Amazon EC2 for a broad array of workloads. Costs up to 20% less than comparable EC2 instances. One of the biggest benefits of this is it actually uses 60% less energy than comparable EC2 instances, and that's really where a lot of the cost savings comes in, as energy is very expensive. It's a big cost in running data centers, so using less energy allows us to sell Graviton at lower cost. Graviton is a general purpose processor. It's applicable to all sorts of things, open source databases being kind of important in the moment, high performance computing, machine learning, containerized applications go great on Graviton, multi-architecture containers, so you can actually run mixed architecture in your environment. We see a lot of customers, of course, running web servers and API servers, as well as the ever popular machine learning. Just wanted to talk a little bit about the ease of adopting Graviton with ISV support for Graviton, like StarRocks has. This is seamless. There's a seamless amount of AWS managed services that run. You can just upgrade to the latest Graviton version and enjoy. Elastic MapReduce also is one of those things that just works. Lambda as well. AWS Lambda is our kind of function, serverless function running service. And if you're running Lambda managed runtimes or base images, this typically just works as well. If it doesn't, then typically you need to look at like shared objects or native modules, JNI type things. There may be some architecture specific things in your code. What's typically very easy is Linux interpreted languages, just-in-time compiled languages like Java. Really, all you have to do there is select a ARM64-based Amazon machine image, run that on the Graviton instance of your choice. Extra bonus easy if your application is already containerized. These are some of the easiest workloads to migrate. What takes a little more work, compiled languages do need to be recompiled. So you can load your source code onto an ARM64-based Amazon machine image. That's the AMI here, AMI, that's how we pronounce it, and compile it. A lot of compilers support running emulation to compile for a different architecture, but you'll see it's a lot faster to compile things natively. The highest rewards come with the most work, of course, but current versions of .NET work on Linux and work on ARM64-based architectures. So if you're willing to put in the work and you have a Microsoft-based workload, migrating that to Linux and running that on Graviton has the most rewards in store for you. I told you that AWS managed services that expose instance choice, lots of those support Graviton. This list is ever growing. Since we're here really to talk about EC2, I just wanted to share this with you to say, if you're using other Amazon Web Services that expose instance choice, check out the Graviton offerings. Those are really cool. I want to talk a little bit about Amazon's own use of Graviton, because this is a story that's grown over time and it has some impressive numbers in it. I know the StarRocks numbers were pretty impressive as well, so I'll keep this pretty short, but we started using Graviton on the retail side of Amazon in 2021. We use this kind of internal measure called a normalized instance. We use this unit to kind of allow us to make meaningful comparisons between different instance types and sizes in EC2. And in Prime Day 2021, we increased our normalized instances year over year by 12.5%. Interestingly, though, for this talk is due to that increased efficiency, we actually used about 6,000 fewer physical servers than we did comparing that to Cyber Monday of 2020. So year over year, less physical servers, even though we're continuing to grow in instances. In 2022, we continued to grow the number of instances. I told you about that normalized instance. That grew by about 12% year over year. Comparing that, yet the overall server equivalent footprint was 7% larger. So even though we're growing the normalized instance way that we use to compare EC2 instances, the actual physical server adoption was less than that growth. 2023, we're using tens of millions of normalized instance hours, really adopting that Graviton 2-based instances and running, like Amazon's powered by so many different services. The 2600 here is kind of meaningless until you look at it in terms of 2024, when we doubled the number of distinct Amazon services that were being served by Graviton instances. And that really allowed us to continue to double down. In 2024, over 250,000 AWS Graviton chips to power more than 5,800 distinct services. We also started to use a lot more of these other custom silicon I mentioned, the Inferentia and Trainium. We used a cluster of over 80,000 Inferentia and Trainium chips to power Prime Day's AWS artificial intelligence, the Rufus, things that Amazon does with AI. In 2025, in addition to powering nearly half of the compute needed for Prime Day this year, Amazon also deployed 87,000 Inferentia Trainium chips, custom silicon chips for that deep learning and generative AI. We talked about EC2, but I mentioned those other AWS managed services because I wanted to talk about these as well here. Like ECS is our elastic container service, and it has Graviton options. You can choose processor architecture in ECS, and Amazon launched an average of 18.4 million tasks in ECS on AWS Fargate. AWS Lambda also supports processor architecture choice and handled over 1.7 trillion invocations per day during Prime Day 2025. Amazon Aurora database that we have supports customer instance selection as well, and our Graviton-based instances. So you can choose Graviton-based instances for Aurora. On Prime Day, Aurora processed 500 billion transactions, storing something like 4 petabytes of data and transferring nearly a petabyte of data. And the last one I'm going to talk about here is Elasticache. Amazon Elasticache also supports instance choice. So if you think back to that slide of AWS managed services that support Graviton, Elasticache is one of those. And it peaked at serving over 1.5 quadrillion daily requests, over 1.4 trillion requests in a minute. That was kind of the peak numbers there for Elasticache. Kind of amazing numbers. Just wanted to share that with you all. So I want to summarize what we've learned about Graviton briefly. AWS Graviton instances, 40% better price performance compared to other EC2 instances. That's 20% better price and 20% better performance together. AWS Graviton instances using 60% less energy and supporting a broad spectrum of workloads. Like I said, it's a general purpose processor. Generally, it works for everything. Most Linux and open source applications can easily run on multiple processor architectures and are well suited for running on Graviton. All the popular Linux distributions and an extensive ecosystem of our beloved independent software vendors work on Graviton. StarRocks works very well on Graviton. I'm going to tell you a little bit about that in just a second. Amazon instances are available in nearly all regions today. These are kind of the published results that I got from StarRocks when we were validating StarRocks on Graviton 3. And what customers saw there was a 50% price performance boost with StarRocks using the C7G. That's the compute optimized 7th generation of EC2 instances and the 3rd generation of Graviton chips in those EC2 instances. These were really published standards based on 1 terabyte scale TPC-H benchmark tests comparing the C6i instance type with the C7G instance type. showing average performance improvement of about 30%. Combining that with a 15% cost optimization for the instance is how we got to this 50%. It was actually 53% better. So we talked a little bit about Graviton 4, and these are kind of fresh off the press numbers. So unpublished, but I wanted to share them with you since these are kind of new performance increases. Running the SSB 1 terabyte test comparing, like I said, we like to compare Graviton 3 to Graviton 4. 119% performance improvements comparing Graviton 4 to Graviton 3 in the TPC-H benchmark 1 terabyte test set. Really impressive numbers. 90% more cost effective in that SSB 1 terabyte testing, looking at different instances. 22% more cost effective comparing the TPC-DS 1 terabyte test compared to Graviton 3. All told, these are really impressive numbers. I told you what my call to action was going to be. Please do try AWS Graviton for all your workload needs, and definitely try StarRocks on AWS Graviton. That's what I've got.
Thank you, Mario. Thank you. Yeah. So now let's take a look at the questions. Let me share this screen first. Okay, so be sure to join. Also, try Graviton, and also be sure to join the StarRocks community, please. If you have any question, please type them in the chat. I think we have around 3 minutes to handle all the questions. So first question from Gus. We currently deploy StarRocks on EKS using the provided Kubernetes operator. Are Graviton instances also available on EKS?
Yes, they are.
Okay. Are there any other questions? Version of StarRocks that was the comparison test run on 4.0.0 RC1, which was just released yesterday.
That's awesome. The 50% price performance was using StarRocks 3.3.
Yeah.
But that's a little bit older benchmark.
Oh yeah, that was the last Graviton 3. Okay, that's all of the question we have from the audience. Actually, I have one question for you. So I do see like better performance numbers for the SSB test, like compared to the TPC-DS test. SSB test is more like scan bottlenecked, so scanning data like takes more time, and um the TPC-DS test is more like compute heavy, right? So the scan is actually from memory. So do you have any insights of like why that is? Like Graviton actually has like more advantage when it's like CPU like talking to the memory, a lot of data is moving around with that as a bottleneck, if that makes sense.
You know, the Graviton 4 based instances have 12 channels of DDR5.
Oh yeah, that's
So there's really some impressive memory bandwidth. It's like in my memory test, just like testing for myself, I see the fastest memory performance on Graviton 4 of any
yeah
I've tried.
Yeah, because like StarRocks does have like caching capabilities, so all of the tests are hot. So basically, all of the data are like in the cache, like inside of the memory, right? I think that played a huge deal. You know, that's why like as we see like Graviton 4 got like those crazy performance boosts on like the SSB benchmark test, which is like more scan heavy, more like IO bottleneck.
Super cool.
Okay.
Thank you for having me.
Yeah, thank you. Thank you for the answer. And we love to wait, there's another question. We love using Graviton, but don't know if it's worth upgrading to the newer generation. How should we think about migrating from our X6 and X7 nodes to X8 machines?
So these are the highest memory instances that AWS has to offer. While Graviton 4 costs a little bit more, at least what we've seen with initial StarRocks testing is there is still a price performance increase with Graviton 4. Even though the Graviton 4 instances cost a little bit more, you might be able to run less nodes or smaller nodes and get the same performance.
Thank you. Thank you for the answer. That's all we have for today. Thank you so much, Mario, for giving this amazing presentation. Thank you everybody else, for joining. See you guys again next time. Appreciate that. Thank you.